Good morning, students. So we are at the end of the chapter according to text, but still we have to solve some problems, additional, then some additional theory that is not described in our text, but some additional theory we need to discuss. We do some practice also. Okay, so we continue in 11th lecture. Answer the following question: when a low flying aircraft passing overhead, we sometimes notice a slight shaking of the picture on our television screen. Suggest a possible explanation. So, this is actually not the calculative base but logical question. Word use possible explanation. So, this is our TV set and this is our suppose satellite. These waves are coming over here. Okay, so when aeroplane is passed through that and suppose this plane is in the path of that, then there is one possibility we cannot get signal for a moment and we get shaking. This is one way. Second way, suppose a plane is somewhere here and this ray is incident and then reflected back. One way is directly and other one after reflection and it gets interfered, then also it is possible. So there are different reasons. Okay. Second one, as you have learned in the text, the principle of linear superposition of wave displacement is basic to understand intensity distribution in diffraction and interference pattern. What is the justification of this principle? So we learn in the superposition principle the displacement y is the vector sum of the displacement that due to each one. We discussed for one dimension, so just we have added, other we have to use vector addition. Okay, this is for linear superposition of wave, and we can apply it. So distribution of the energy is because of that, where the constructive energy is added and where destructive is subtracted, but energy remains constant. But if intensity is very large, then this may not happen. If intensity is very large, then when it passes through the, so we can say that where intensity is not very high, then we can use the superposition principle. Okay, so this is you can say limitation also. This is the limitation of superposition principle for high intensity light. Then one more last one. In deriving the single slit extraction pattern, it was stated that the intensity is zero at an angle of n lambda upon e. Justify this by suitably dividing the slit to bring out the cancellation. So here for nth minima, this is your angle n lambda upon e. So what we do, suppose we have slit and this width of the slit is a. So dividing the slit in n equal parts. So width of each one. Let us say A prime is equal to A upon N. Now, condition to have first minima what is the condition? That theta must be equal to lambda upon A prime. Because A prime is equal to what? Lambda upon A upon N. And therefore N lambda upon A. So each part gives you first minima. At the same angle, we get N minima for complete sleep. Okay? It means that the angle at which one gets nth minima for a sleep at the same angle, first minima due to nth part of the our preparation. Okay, the ratio of intensity of rays emitted from two different coherent sources alpha for the different interference pattern formed by them through that. This is the formula. So actually, these are the additional questions. We're going to solve it. The ratio of intensity of rays emitted from that is alpha. So here I1 upon I2 is equal to alpha. And we know that I proportional to amplitude square, so I can write I1 square upon A2 square. So which means that A1 upon A2 is equal to root alpha. Okay, we want to find Imax upon I mean. So Imax क्या મળશે તો very constructive interference produce થાય અને A2 I mean destructive. Okay. Okay. Imax હવે હું વધારે સ્ટેપ નહીં લખું એટલા માટે કે હવે આપણે સ્પીડમાં કરવું છે થોડું સ્ટેટમેન્ટ લખ્યું તો વાર લાગશે. તો Imax એટલે શું છે એમ્પ્લિટ્યુડ શું થાય એડ A1 plus A2 square and I mean is proportional to A1 minus A2 square. And therefore we can write Imax upon I mean is equal to A1 plus A2 whole square upon A1 minus A2 whole square. So this you can write as A1 upon A2 plus 1 square upon A1 upon A2 minus 1 square. A1 upon A2 is root alpha, so root alpha plus 1 square upon the root alpha minus 1 square. So this is the relation. We get this. Now after we use Imax upon I mean. So directly I write Imax plus I mean upon Imax minus I mean. So this you can write as root alpha plus 1 square plus root alpha minus 1 square upon root alpha plus 1 square minus root alpha minus 1 square. So no square is you get alpha. Here the alpha, so it becomes 2 alpha. 1, 1, so you will get 2. And in a positive term also in negative it will cancel out. Divide by alpha is here, alpha is will cancel, 1, 1 is also cancelled, and here by add thirse, so you will get 2 root alpha. So you will get alpha plus 1 upon root alpha. So this is 4 years. You will get 4 years. So this will be 2. Here 2 hours, here we 2 hours, it becomes 4. So finally you get this one and you are getting it. હવે અહીંયા જે મારે ખાસ એક્સપ્લેન કરવાનું, this is very basic question. આના આધારે ક્વેશ્ચન્સ પૂછાતા હોય છે. તમને ઇન્ટેન્સિટી આપેલી હોય, એમ્પ્લિટ્યુડ may be given, અને એના આધારે તમને આપવામાં આવેલું હોય. This is method how to calculate. But if I take a reciprocal of this, it is called visibility of fringes. If I write like this, it is called visibility of fringes. So it becomes 2 root alpha upon alpha plus 1. If both intensity is same, then alpha is 1. See, intensity is same, so alpha is 1. So you will get alpha is 1, so 2, alpha is 1, so 2 will become 1. If A1 is equal to A2, or you can say I1 is equal to I2, you will get visibility 1. And if suppose this is very large value, so this we can neglect it. Then A1 is intensity of 1 is very large compared to this one. So our ratio મારો મોટો આવશે, આ મારો ratio જો મોટો આવશે, this is very large. So this is very large, so this will become very small. આ નાની value આવશે. So if A1 is very large than A2, then it's very nearly equal to 0. What is the meaning of that? That if you want to see very clear image or very clear fringes, then both the intensity should be same. So અહીં મેં તમને ડ્રો કરવાની ટ્રાય કર્યું છે. આ જ્યારે એમ્પ્લિટ્યુડ સેમ હોય તો આવું બતાવશે, અને જેમ એમ્પ્લિટ્યુડનો ડિફરન્સ વધતો જશે એમ એમાંથી આવી બનશે, એમાંથી આવી બનશે, ઝાંકી you cannot differentiate two things. તમે જુદી પાડી શકો નહીં, અને જુદી પાડી શકે એવી જો હોય તો મારે શું, આ મારી કન્ડિશન છે, A1 must be equal to A2. તો આના આધારે ક્વેશ્ચન્સ આવતા હોય તો you can answer. Okay, then I go for next. Young double slit experiment. We used to determine the thickness of a thin transparent sheet. Use young double slit experiment. An experiment arrangement is shown here. This is the S1, S2 sources. Transparent medium heavy refractive mechanism is shown in the figure. That the center bright fringe which was obtained at point P on the screen on the absence of the thin sheet shifted to point P. Derive the formula for the thickness of the sheet. So જે અહીંયા મને મળતું હતું એ shifting થઈને અહીંયા જતું રહે છે when you introduce this one. So in the absence of sheet, very important, path difference is 0, equal to 0. Why? Because S1A is equal to S2A. Now when you introduce sheet, so this way passing through that sheet travels, it takes more time to reach P. So there is a path difference, and that because of that there is a phase difference. So ये આપણે કેટલો ટાઈમ વધારે રહેશે એ આપણે જોવાનું છે. તો કે time taken to cross sheet એને આપણે T1 is equal to શું થશે? તો કે thickness T upon velocity is equal to P, velocity is equal to what? C by N. where n is the refracting index. It means the nt upon c. So this takes this much time more. આટલો ટાઈમ વધારે લેશે. n upon c into t. આટલો ટાઈમ વધારે લેશે. So path difference કેટલો થઈ જશે? તો આટલા ટાઈમમાં આ વધારાનું વેવ ટ્રાવેલ કરશે કેટલું? તો વેલો બિલ મલ્ટીપ્લાય બાય c. તો path difference is your time t1 into c. It means that nt. So this is nt, and then what is the distance covered in time t1? So distance covered by another ray or another wave in time t1 is equal to velocity in the air multiplied by nt upon c. Actually this already we discussed in ray optics, પણ આપણે ફરીવાર આ કર્યું છે nt. So now what is the path difference? So path difference, so here nt distance, and for the first wave it is t distance. So it is t n minus 1. So because of this path difference, how much center is shifted? Okay, x. How much shifted is x? Here it is x. Okay. So we can write, we have path difference is equal to x d upon d, and is equal to t n minus 1. And therefore we can calculate t is equal to x d upon capital D n minus 1. Sometimes how many fringes are shifted એ આપેલું હોય. Suppose 3 bright fringe, center comes over third, so this x equal to 3 lambda d upon d, because 1 is lambda d upon d, so 3 means 3 lambda upon d. So you can put x equal to this one and you can calculate. See, put this value, suppose n shifting. Okay, how many? N. So now additional one, now I discuss additional one. So suppose n lambda d upon d, this is the shifting, and d upon capital D n minus 1. So this n is number and this n is refracting index, so just I put n prime here. So this is cancelled, this is cancelled. So n prime lambda upon n minus 1. So this is the thickness. If suppose it's shifted by 3, then this is 3. It is shifted to third bright or third dark, maybe anyone. So it આપણે calculate કરી શકીએ. So this is also very important problem. આના આધારે, આ કોન્સેપ્ટના આધારે ક્વેશ્ચન પૂછાય તો તમે આન્સર આપી શકો. ઓકે, થેન્ક યુ. Okay. Prove that the when unpolarized light passes through the polarized, the intensity of the transmitted light will be exactly half to the incident light. So if this is unpolarized light and it is incident on the polarized light. So what is the intensity? We already mentioned in the theory, this becomes I0 by 2 if this is I0. And we want to prove it here. So this is your, suppose I take one vector here and this is the optical axis. So આમાંથી જે બાદ આવશે આ વેક્ટરના કારણે કેવું હશે? તો I is equal to I0 cos square theta for one vector. There are so many vectors, they are making angle different one. So it varies from 0 to 2 pi. સમજો, એક વેક્ટર છે 0 એંગલ બનાવે છે, બીજો છે 0 થી કરતા થોડું વધારે, more than that, more than that, more than that. એમ કરતા 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 if I take all these vectors which are incident on the polarizer, which angle varies from 0 to 2 pi. So I have to integrate it from 0 to 2 pi d theta. So you know this is well known integration, it becomes half. કઈ રીતે કરી શકાય? cos square theta is equal to 1 plus cos 2 theta by 2. અને cos theta નું integration શું થશે? 0 થશે. 1 plus cos 2 theta by 2 is integrated. So half is coming outside, 1 plus cos 2 theta. Okay, so if you do calculation, 1 upon 2 pi. So you will get this value. Okay. So આ રીતે તમે calculate કરી શકો 0 to 2 pi upon 2 pi. So half value આવે cos 2 theta નું 0 to 3. Okay. A slit of with D is illuminated by white light. For what value of D will the first minima for red light wavelength appears at theta is equal to 15 degree. So minimum or any condition is D sin theta, or you can say D theta. In text માં આપણે એવું કીધું sin theta ને theta ની અંદર લીધું છે, પણ D sin theta is equal to n lambda. Here n is equal to 1, and therefore D sin theta is equal to lambda for red color. So I put the value 6500 angstrom. So this is for first one. At the same angle is same, and D is also same. So મારે કયા માટે જોઈએ છે? The violet માટે. This is the wavelength. તો ત્યાં મને શું મળવાનું છે? So if it is a minima, then n may be 1. So 1 તો possible નથી. If n is equal to 1, then it should be 6500. If n is equal to 2, then double of that. So એ પણ possible નથી. So આપણે we check for D sin theta is equal to n plus half lambda v. કારણ કે it is less than that one. So આ જે છે n ની વેલ્યુ મારે કઈ હોવી જોઈએ એ મારે ચેક કરવાની. We put it here 6500 angstrom is equal to n plus we don't know whether constructor minima or maxima. મિનિમા નથી લાગતું કારણ કે n is equal to 2 આવે તો આના અડધું જ હોવું જોઈતું હતું. 3250 તો આપણે કહી દે. If it is 3250, then you can say the second minima of violet. પણ એવું નથી, એટલે કે બીજું કઈ હશે. So we are checking for that 4333 angstrom. So coming here will become 1.5 around and plus half, and therefore n is equal to 1. It means that first maxima. It means that first maxima you will get for violet where first minima of the red. સમજમાં આવ્યું? Red નું first minima